It's Charles here from Peterborough Tuition. I just wanted to put this video up because I've been speaking to... Yeah, hi, it's Charles here from Peterborough Tuition. I wanted to put this video up because I've been speaking to some parents recently. That's the time of the year when, like most tutors, there's an uptick in new inquiries when children have gone back to their school for the year, and there's a coming closer time where people are thinking they've got entrance exams such as for private schools or for grammar schools coming through, and therefore they're thinking about either perhaps running a DIY homebrew program to support their own children's educational training, or perhaps they might be thinking of group tutoring or one-to-one tutoring, and all have their place. All can work. All are good, all are bad. I'm unbiased on that. All are good, all are bad. But one of the things that'll often crop up is that the maths side of what someone's got to learn can often be lacking. In simple terms, the maths that most students have is a bit raggedy and a bit slow. By the end of the year, the vast majority of them will have moved up quite a few notches in accuracy and speed. But the sooner that they can address those gaps, the better. So when I have an intro session with someone, I'll normally have a little play around with some maths, see how they do with various number crunching exercises. Nothing heavy, no heavy lifting, but just sort of playing around and getting a flavour and a feel of what they do know and where they're a bit stuck. So this is just a throw out suggestion to you guys, parents that are either in the 11 plus preparation process, or you're thinking about it, or perhaps your son or daughter has had a few knockbacks due to COVID and so on, and it just means that although they're in a senior school, state, private, grammar, whatever, they're in their, say, their KS3s, KS4 years, and they're just a bit sluggish on their maths. Couple of things for you. Right. Excel. I love Excel. It just allows you to crunch numbers and play around so easily, and also draft up tables. So what I've got here is a really simple table. It's a multiplication table, but it's on steroids. It's slightly bigger. I've drawn a 20 by 20 table. Now, the reason I've done that is I think it's a bit of a short-changing exercise if your children just learn the 10 by 10s. If all they do is go out to the 10 by 10s table, some of the repetition of number patterns, some of the ways that numbers roll, they'll miss. So if you go back to, say, the imperial time, everyone would learn 12 by 12. As a minimum, they should be looking at 12 by 12s. Now, if you're looking at sitting entrance exams to a state school like a grammar school or a private independent exam, the examiners will love to test your children by throwing in some awkward numbers such as 13 times something, 17 times something, 19 times something. So now is the time to include in your 10, 11 and 12 times tables your 13 times table, your 15s, your 17s and your 19s. The more practice they have on remembering and writing these tables out, and there's some ways of writing them out that's going to nudge them, the more practice that they have on doing this, the better. As a simple test, you should be able to throw out to your child a question. What's 9 times 12? What's what have we got there? 12 times 8. What's 8 times 7? You should be able to throw that out, and they should be answering you back within, say, 2, 3, 4 seconds. If not, they don't have a strong grasp, because what they might be doing is, you might be asking them 11 nines, or they might be doing in their mind 9 nines and then having to count up, or perhaps you're asking them what is 12 sevens, and actually they're doing 12 fives and counting up. That's taking up time, and it's adding the possibility of an error. If they have the number embedded in their mind, they will just fire it back. So you need some drills. So what I'm saying is, you need to get a table up on Excel or on a bit of paper, whatever, and get them to be rolling through those tables. They need to be thinking about the numbers, they need to be able to live the numbers and understand them. Now, on another video I can talk about some of the repetitive patterns, but one of the key ones that's worth noticing is if you look at the nines, the 9 times table, whether you go horizontal or vertically, one of the key points about 9 times tables, if you look at them, the sum of the digits always adds up to 9. Now by that what I mean is if you look at 4 9s, 36. If you sum 3 and 6 you get 9. Come to there. 8 9s, 72. Sum 7 and 2 you get 9. Over here 13 9. We're in a wild and wacky area now. Ooh, frisky. We're in the old Wild West here. 13 9s. 7 plus 1 plus 1 is 9. So where that's useful is when your son or daughter is comfortable with the tables. When they get hit by a maths question which has got a multiplication of 9, they've got a really quick check. When they run that calculation, does the sum of the digits add up to 9? If it does, they're right. They're hopefully right, they got the right multiple. But if the sum of the digits of their answer adds up to 7, 8 or something like that, well, I've got to say they really need to revisit that number because there's a strong chance, nearly 1, that there's an error. So you got some rules there. There's a few other rules and a few other patterns we'll play around with later. But firstly, they need to learn that. They need to learn the table, and I'd suggest they roll all the way out to 20, because 20 is beautiful. 20 is just double 10, and 10 is just double 5. So there's certain repetitive patterns there. Now the other one is the squares or the rectangles I've highlighted are all the square numbers. So if you look there, 8 8's 64, 9 9's are 81, 12 12's 144, 13 13's 169, and so on. Those are again really useful numbers to memorize. The reason they're really useful is that you'll normally find in the 11 plus and even on 13 plus papers they'll throw in there some questions on squares and powers. I've got a little tab on squares and powers in a moment. I'll touch upon those. And if your son or daughter, if they are really up on knowing their powers, when those questions come up they'll be able to answer them much quicker. They don't have the luxury of sufficient time to work out the answer to all the questions. It's not there. They need to be able to know the answer to the questions, and that's quite a different thing. So the more that they have got an automatic recall their powers, the easier life's going to be. So step 1, you need to get the multiplication tables en masse, the whole lot, locked down. Step 2, you need to get the powers, the square powers, is literally 3 times 3, 5 times 5, 6 times 6. Now, there's 2 other things that come out from this as well. Your child will need to know, certainly 11 plus, they need a surface knowledge, and by 13 plus papers, if they're going for independent entrance at 13, they'll need to have a bit of a working knowledge of what prime numbers are. Prime numbers, broadly, are numbers that can't be made by multiplying 2 other numbers below them. So if you think about 8, for example, 8 isn't a prime number because, as you can see, you can make 8 by 2 times 4. Someone might say all even numbers can be multiplied by 2. Okay, great. Let's look at 21. 21's an odd number, and as you can see, 21 can be made by 3 times 7. But if you look, there's 21, there's 22, there's 24. No 23. 23 is a prime number. It's a number that cannot be made by multiplying 2 lower valued numbers. And before, as some children say, what about a fraction, multiplying fractions together? No, if you multiply a fraction by a fraction, you're still going to get a fraction. A fraction by a whole number. We're not talking about fractions here, okay? We're talking about whole number integers. Forget those. So there's no whole numbers you can multiply to make 23. So if your child becomes really conversant with the table, and look, 20 by 20 gets you up to 400, 10 by 10 gets you up to 100. If they are strongly conversant with the table, the next trick you can ask them to learn is come over to primes, like this, and have them write out a table that goes from 1 to 10, next line from 11 to 20, and then from 21 to 30, and all the way down. You can go down as far as you like. I've got this table going down to 329. But what you can do is play around with having them draft the table and then getting them to cross out or delete all the numbers that appear in the times tables. So here is the list of all the numbers that can be multiplied by a pair of lower numbers. So it's if you ignore 1 for a moment, that's a trivial answer, and if you ignore all the 2's, using odd numbers, 3 times 5 and 3 times 7 and 7 times 11 and 13 times 3, etc., you'll make a load of numbers up. But some of them are not ones that can be created. Now obviously after 2 all the other even numbers disappear, after 5 all the 5s disappear, and after 10's gone because of 5 and 2 already. So very quickly, and I've only put the 2, 2, 3, 5, 6, 8, 9 and 10 in as placeholders as such for the columns. They'd actually not be in the list. All the remaining numbers are prime numbers. Now if your child can remember that, it will help them. So they need to really remember all those prime numbers, including that one, and one's trivial, but include that. Those numbers are the prime numbers. They'll come up in certain questions to do with how do you make this number, 4,302 for example, which 3 prime numbers make it, that type of thing. Now, if they know the prime numbers, they'll be able to work those out quicker. And the prime numbers can be generated, basically they're the leftovers from your times tables. So learning multiplication tables, key. Learning prime numbers, key. One more table, powers. This might look a little bit odd to you as such, but that little symbol with the carrot, or the little top hat, is just a maths way of showing a power. So this is just a list on the left. These are, say, the values I'm using, 1 down to 25. And 2, this column is the square, these are the cubes. So 2 squared is 4, which is as per the times table. 2 cubed is 8. 3, if you think about 3 squared, it's 9. 3 cubed is 27, and the 27 is literally 3 times 3 times 3, just like 8 is 2 times 2 times 2. Now, your child will benefit by being able to get their head round and be fluid with square numbers and cube numbers. Now, in the same fashion, the opposite of each of these numbers is square roots, cube roots. Now, if we look here, if you think about 4, the 4 has come from 2 squared and the 8 has come from 2 cubed. Well, 4, the square root of 4 is 2, and for 8 the cube root is 2. So you can go both ways, and again you haven't got to go all the way down right down to 20s and so on, but certainly, you know, up to the square of 100, square of 10 for 100, and the cube of 10 to make 1,000, and going the other way, the cube root of 100, square root of 100 to make 10, and the cube root of 1,000 to make 10. That level of number crunching they need on hand, instant recall. And it can be built. Even if there's gaps, they can build on it. So, as a suggestion for you, have them learn their tables up to, say, at least get them lifting numbers up to the 10s, 11s and 12s ASAP, then get them to plug 13s, 17s and 19s. They're going to help. Then have them build out their prime numbers. So that will help them grow their prime number knowledge, because that's going to come up in questions. And then linking into that, have them learn their powers, their squares and their cubes. That's square numbers and cube numbers, and then the opposite, the inversion, square roots and cube roots. It's going to help them, because it'll happen, and if you speak to any other math tutors, you're going to have the same kind of comments. The basic building blocks have to be in place, otherwise they'll get screwed around when they do their algebra, they'll muck up things on areas and volumes, there'll be issues on when they're looking at number sequences, various progressions. It's building blocks. The easier and the quicker they are able to answer those questions without thinking about it, because it's been drilled, it's there, the easier they'll amass marks, and they'll be able to have more time free on the difficult questions. These are really just the basics, but the issue is it's there. It's a problem for all students. It's not just your year 4, year 5, so don't feel it's just you guys. I'm working with students that are in pre-GCSE years, and they are rusty on this. So get it locked down, get it sorted, and your children are going to find all their exams going to be much easier. Now, hopefully you've been finding that useful, and yeah, please come back to me if you've got any particular math questions you're stuck on, or VR, MVR, English, whatever. Throw a message up, pop me a message over, and let's see if we can help you with that. It's Charles here, Peterborough Tuition. Hopefully that's useful. Speak soon.